All right, let's do a couple more. Let's do a couple more. Here are 3 words. Finger, refuse, dedicated. Quick little something to ask you guys to do. I want you to come up with the average length of those 3 words. I think we all know how to take an average in this class. If you don't, we'll figure it out right now and we'll revisit it on Tuesday. What's the average length of these 3 words? So this one has 6 letters. This one's got 7. 9. 6 and 7 is 13. 9 is 22. Divided by 3. 7.3? 3. Call it 7.3. On average, those words have 7.3 letters. I want to talk about what that means on Tuesday more, but we know that the average is 7.3. Cool so far? Here's what I want you to do now. I'm going to show you a few more letters on the next page. I'm going to give you 10 seconds to come up with the average length of them as well. Same way. Well, actually, you probably don't want to do it the same way. You want to come up with a more effective mechanism, i.e. maybe guessing. That's okay too. So get a ballpark. There'll be too many to count. Too many to count. Okay, you ready? 10 seconds start, and give me something point something, like 7.3 we did. Yeah? Here we go.
Oh, okay.
You might recognize the soliloquy, greatest movie ever made, ever, without argument. Don't even try. Maybe Back to the Future, maybe. Okay. So, what we're going to do right now, sorry, I just put a bit of that in there too. We're going to mute this for a second. And we're going to talk about what's called either a stem plot or a stem and leaf plot. It depends, I forget which one your book calls it, and every book calls it something, either one or the other. But the idea of this is a way of collecting a bunch of data that's tightly compressed in one way, but varied in another way. And that won't make a whole lot of sense right now, so let's just ask some questions. Anybody guess something like 6 point something for the letter, for the length? Anybody go 5 point something? Anybody go 4 point something? No 4s. Oh, we got a 4. Colton, you're at 4. Anybody below 4? 3 point something? Okay, so 4 point something. We got a low end. 7 point something? Anybody go 7? We got 7. Anybody go 8 point something? No 8s? Anybody above 8? So everything's between 4 and 7. You see how compressed that is? Of all the letters you could have picked, as far as how long they are, you could have gone from 1 to like 13 potentially. But all of you went between 4 and 7. 4, 5, 6, and 7. Stem and leaves work great when the data is compressed in that way. So we're going to call that stem, which in this case is the whole number part of your guess or your measurement. The whole number part of your guess or your measurement. And then technically, I think what usually happens is they put a horizontal or a vertical line. You can also stack them vertically. It's easier to read because of the way they're going to come out horizontally, I think. What are the leaves going to be?
The decimal point?
The leaves are going to be the decimal point somethings, point somethings. And the reason why it's nice to do this is, how many different leaves can there possibly be? 10. 0 through 9, right? And some of you are going to have them repeated. So watch this. 4s. Who said 4? Holt, you said 4 point what? 4.3. 4.3. There you go. Anybody else 4 point something? Okay. How about 5 points? Shout them out.
2, 6.
5.2, 5.6.
0.
0.0. That's all 5s? What you want to do is make sure that each one is occupying the same amount of space as each other one, and you're about to see the histogram begin to grow. 6 point somethings, go!
0.5.
0.5.
0.2.
0.2, 0.3,
0.8.
0.8,
0.7.
0.7. That everybody? Awesome. 7s.
0.
0.0, 0.3. There are like 35 people in this room, for God's sake. Give me one more.
0.1.
0.1. Perfect. Thank you, Renee. All right, that's enough. I'll play, it's fine. Do you see the histogram? If you don't, turn your head 90 degrees to the right. It's there. It's there. So, your leaves, by virtue of their shape, trace out histograms. Now the beauty of this, the reason I like this is twofold. Number one, if you have data that's really compressed one way but varied another way, it's a very efficient way of not having to write. If you're in the field with a notepad, for example, collecting data, it's a very efficient way of collecting it this way. Suppose you're at a mall taking ages for a sample. Everybody appears to be teenagers and 20-somethings. Well, then you put a 1 and a 2, and you just put the ones digit of their age after it each time. It saves you from writing all the 1s and 2s constantly, which is great. And software can set this up. Anybody see the other reason it's really cool? What don't you lose with it?
The raw data.
You don't lose the in-between raw data. It's all there. You get all the raw data like you lost with the normal histogram. It's all qualitative. It's not exactly histogrammic because there's no ranges of the 4, the 5, and the 6, but 4.3, that's a raw data point. 5.2, 5.6, 5.0, those are all raw data points. You're not losing anything, which is pretty slick, actually. Which is pretty slick. Cool? Make sense? Please, Sarah, go.
How would you do this, like, if you were, I don't know, like give me another example of, like, doing this.
You know, I'm not saying it always works. I'm saying this is a tool for when your data is compressed on one scale but not on the other one. For example, if I was measuring the life, how old the engines were in all of your cars, I probably wouldn't do it this way. Because some of you guys might be driving cars that are like mine, like 80 years old. Actually not 80, 75. And some of you might have brand new cars. So you're going to have a wide range of values both ways, first digit and last digit. But the other example, like I said, if I was talking about ages in this room, I might go this route versus writing every single one of them down. Start with a 1, 2, 3, and 4, 5, whatever, and then put the second digit after that.
Okay.
Does that make sense?
Yeah.
I'm not saying it works in every situation. I'm saying it works great in the situations it does work for. And we'll learn as we go through the course which ones work better than others.
Okay.
Cool?
Yeah.
Yeah, good, good, good. I got one more to chit-chat about. Yeah, and I think Sarah brings up a good point. Things we learn about in this course, and I think any course for that matter, they aren't intended to be able to all be used all the time. I'm just trying to give you all the variants I've seen of each of these that work pretty well. And the last one is just called a dot plot. And what I want to do is, I want to collect one more bit of data. Actually, I lied.